Chef Dean, and I'm Math Dad. I'm here to help you help your kids understand math. Recently, we've been talking about how to make multi-digit addition and subtraction just like riding a bike. Our goal is to make sure that our students understand this so well that no matter how much time passes, they can still remember what to do. In the first two videos, we talked about two important skills, math facts and place value. Be sure to check them out if you haven't already. As I talk to parents and teachers, there's one more skill that seems to always be a stumbling block when it comes to successfully doing multi-digit addition and subtraction. Regrouping. What's regrouping? Regrouping is just a fancy way of saying we have to borrow a 10 or we have to carry a 10 over into another place. Sometimes it's also called composing or decomposing a 10. So whether you use the word regrouping, composing, decomposing, borrowing, carrying, they're all referring to the exact same concept. Students who struggle with this often see this idea of regrouping is just a procedure that they've memorized. They don't necessarily understand why they're crossing out numbers, why they're putting ones at the top of their problem. It's just something that they've been shown to do, so they do it. But they don't necessarily know why or when they're supposed to. Today, we're going to take a look at that why and discuss how we can help our students become very flexible with how they represent numbers. Beginning in first grade and continuing through third grade, students are making sense out of what numbers mean. We want to be able to see that a two-digit number is made up of some amount of tens and some amount of ones. We should be able to represent that with models, 2 tens and 8 ones. This is great for students to know, but a skill that's often minimalized is representing this in different ways. It is super crucial to help kids understand regrouping, and that is they should see this could also be 1 10 and 18 ones. Exchanging a 10 for 10 ones gives me a 10 and 18 ones. Or if I exchange this 10 as well, I now have 0 tens and 28 ones. There are many ways to represent a two-digit number. By second grade, students are looking at three-digit numbers, and they should be able to model these with physical models, 3 hundreds, 2 tens, and 8 ones, or with words, 3 hundreds, 2 tens, and 8 ones. But how many different ways are there to represent this? I could exchange one of these hundreds blocks for 10 more tens, and suddenly I have 2 hundreds, 12 tens, and 8 ones. I could now exchange one of my tens for 10 ones, which now gives me 2 hundreds. I now only have 11 tens, but I now have 18 ones. By doing this, it takes advantage of the understanding that it takes 10 ones to make a 10. It takes 10 tens to make 100. And that is exactly what students need to understand when they're doing regrouping. A fun game to play would be giving students the initial amount and asking them, how many different ways can you represent 328 with hundreds, tens, and ones? They may say, I'm going to exchange 2 of my 10 or hundreds blocks for tens, and now I have 22 tens, 100 now, and I have 8 ones. There are countless ways of representing these numbers with different combinations of hundreds, tens, and ones. By the time students get to 3rd grade, they should be working with up to 4-digit numbers. This is 1,000, 300, 2 tens, and 8 ones. And if students understand this and the fact that it takes 10 ones to make a 10, 10 tens to make 100, 10 hundreds to make 1,000, once again, we can exchange our 1,000 for 10 hundreds, which would give us 0 thousands, 13 hundreds, 2 tens, and 8 ones. Once again, a great thing to have kids to do is give them a 4-digit number and ask them, how many different ways can you represent this number using thousands, hundreds, tens, and ones? So, how does any of this help us with regrouping? Once students have developed flexibility with how to write numbers in many different ways, when they see a problem like this, and they've learned to represent it as 2 tens, 8 ones, plus 3 tens, and 4 ones, when we add these together, we get 5 tens and 12 ones. But because of the flexibility that they have learned, is they know that I can take 10 of my ones and exchange it for a 10. Now I would have 6 tens, 2 ones, or 62. This might also look like 2 tens, 8 ones, and I'm adding 3 tens and 4 ones. I get 5 tens and 12 ones. And again, because of the work that we've done, writing numbers in many different ways, we can say we have 10 ones, so I can move them over here, and this would equal 6 tens and 2 ones, which gives us 62. Another way this might look prior to students understanding the standard algorithm is to do something like this. 8 ones plus 4 ones is 12. And 2 tens plus 3 tens is 5 tens, or 50. And now when I add everything up that I have 62. And now we're one step away from the standard algorithm, which would be placing this 1 at the top as what we call carrying 1. So what about subtraction? How does developing flexibility in rewriting numbers multiple ways help me with borrowing? If we have 34 minus 28, I start with 3 tens and 4 ones, and I need to remove 2 tens and 8 ones. I don't have enough ones to take 8 of them away, but my flexibility has taught me that I can rewrite 3 tens and 4 ones as 2 tens and 14 ones. Now I have enough to take away. When I remove the 8 and I remove the 8, I'm left with 6. I remove the 2 tens and I remove the 2 tens, and I'm just left with 6 ones. So by rewriting 3 tens and 4 ones as 2 tens and 14 ones, we were able to do the subtraction. If I don't have models available, I might have to do this with words. I can say 3 tens and 4 ones, and I'm subtracting 2 tens and 8 ones. I can't subtract 8 ones from 4 ones, but I can rewrite this instead of 3 tens and 4 ones as 2 tens and 14 ones. And now, using my math facts, I know that 14 take away 8 is 6 ones. And 2 tens take away 2 tens gives me 0 tens. So again, I have 6 ones, or just 6. If I want to get one step closer to the standard algorithm, I might introduce the idea of I have 3 tens
And these are my ones over here, 3 tens and 4 ones, 2 tens and 8 ones, and think about it as a tens and a 1 chart, 4 ones minus 8 ones. I can't do that, but I can rewrite this and change the 3 to a 2 because I'm taking one of the tens, and now I have 14 ones. So 14 minus 8 is 6. 2 minus 2, or 2 tens minus 2 tens, is 0 tens, and I get, again, I have 6. And now we're one step closer to the standard algorithm where we would actually be borrowing of 3, change it to a 2, and place a 1 up. You can see the relationship and how close we are by developing the skill of rewriting numbers in as many different ways as we possibly can. Math facts, place value, regrouping. When we give students time to develop these key skills and don't rush them into processes and methods that we as adults feel is most efficient, we give our students time to develop deep understanding of the math that they're doing, and that is how we help make multi-digit addition and subtraction just like riding a bike. My name's Jeff Dean, and I'm Matt.